All right, in this video I'm going to talk to you about another method to find the volume of a solid. We've had two so far, the disk method and using cross sections. And today we're going to talk about something called the shell method. So let's just recap with the disk method. The disk method uses the volume of cylinders that are stacked inside of the three-dimensional shape in order to find the volume of the three-dimensional shape. So that's the disk method in a nutshell. The variables that we use to write the volume of these cylinders is with respect to the axis of revolution. And that's going to be important when we talk about the shell method. So when we talk about the disk method, let's just look at this example. We've got the function y equals 3/4 x. And we're going to rotate that about the x-axis. So in order to find the volume of this three-dimensional solid, we need to find the volume of each cylinder. And each cylinder has a radius that is dependent upon where we are along the x-axis. And that'll determine how high it is because of the function 3/4 x. So we've got the radius there, 3/4 x. And since we're rotating about the x-axis, we're using the x variable in our equation, in the formula for the solid, for the volume of the solid. So if we're using the disk method, which we've done a few times now, we know that we're integrating along the x-axis because these are stacked along the x-axis, so we're integrating from 0 to 4. Pi times the radius squared times the height of each cylinder, which is just some small change in x. All right, I'm going to remove pi because it's a constant. I'm going to square 3/4 x, so that's 9/16 x squared. Now, I could pull out the 9/16 because that's also a constant, but I'm just going to leave it in. So now I'll find the antiderivative of 9/16. So x squared. So add 1 to the exponent, that's x cubed. Divide by 3, so that's 9/48. And I'm going to evaluate that from 0 to 4. All right, so if I plug in 4 for x, I get 64. If I plug in 0 for x, I get 0. If I know the math already, 9/48 times 64 is 12. So using the disk method, the volume of that solid is 12 pi cubic units. Great. That was a good review, I hope. All right, now let's talk about the shell method. The shell method has its benefits, and we'll talk about those benefits later on, but first let's just talk about what the shell method does. So if I look at the shell method, the volume of solids of revolution are found by finding the surface area of cylinders that are nested inside of each other inside of this solid. So think about like those Russian nesting dolls, where you have one doll inside of the other, inside of the other, inside of the other. That's kind of what's going on here. But instead we're nesting cylinders, one within the other. So think about if you take a stack of paper and you roll that paper up into the shape of a cylinder. You see that, at least along the outer edge, you've got a thickness of paper that is creating a solid. Now imagine if that entire cylinder that you've created by rolling up those papers was completely filled with other papers that are rolled up inside. We will get a three-dimensional solid. If we find the surface area of each one of those pieces of paper and add those together, that will give us the volume of that three-dimensional shape. So that's the premise of the shell method. So I've created one cylinder here, and if I write oops, that's the wrong one. Let's use if I were to draw another cylinder stacked inside of this one, you can see now that that second cylinder I drew is nested inside of the other one. And if I had better drawing skills, there would be an infinite number of cylinders that are stacked in between those two that I just drew. And if I draw another cylinder that's stacked outside of those. So all of these cylinders I'm drawing are nested cylinders. One is inside of the other, which is inside of the other. So if I can find the surface area of each one of those cylinders and add them together, that will give me the volume of this shape. Okay, we're going to use the same problem. The difference with this is that variables are with respect to the axis that's perpendicular to the axis of revolution. Don't worry about that yet. It's something that you'll come back to. So we're going to use the same problem that we did above. We're going to rotate 3/4 x about the x-axis. All right, so first thing that's important is remembering the surface area of a cylinder, which is 2 pi times the radius times the height. So if we look at the radius of this cylinder now, it's a little different than when we were using the disk method. All of these radii are exactly the same length. So all of those radius are exactly the same length. What length they are, we're not sure. So we're going to say that, oops, I did not want to do that. So we know that the radius, though, even though we don't know what it is, it's constant, and it's some y value. It's some height off of the x-axis. The height of the cylinder now is, since we wrote the radius as a function of y, the height of this cylinder must also be a function of y. So we've got a little bit of work to do here. We know that the height is determined by where we are along this graph, along this equation. So to figure out that height, we need to take the equation, oh, my thing keeps moving around, which was y equals 3/4 x, and we need to write it with respect to y. So x equals 4/3 y. All right, we know the x value. We know from the y-axis then, this line is 4/3 y units away from the y-axis. I know that this line here is 4 units away from the y-axis. So that means the height of my cylinder is going to be 4 minus 4/3 y. If I were to draw one of those other nested cylinders in here, the radius is still some y value, and the height is still 4 minus 4/3 y. Okay, let's find the surface area of one representative cylinder. To find the surface area, that's 2 pi times the radius, which we know is some y value, some y value, times the height, which is 4 minus 4/3 y. And each one of these cylinders, these pieces of paper, if you will, that are stacked inside of each other, have a small little tiny depth or thickness to them, otherwise there would be no volume. So we'll multiply by that dy. Now everything is with respect to the y-axis, so we're going to be integrating from 0 to 3. All right, I'm going to now use my integration skills. I'm going to pull out the pi. I'm going to leave 2 in there. I'm going to distribute the y and the 2 into those parentheses, so that makes this 8y minus 8/3 y squared. Finding the antiderivative then, I get 4y squared minus 8/9 y cubed, and I will integrate that from 0 to 3. Okay, 3 squared is 9 times 4, that's 36. 3 cubed is 27. 27 times 8/9 is 24. And then if I plug in 0, I get 0. 36 minus 24 is 12 pi. Okay, we got the same answer with a different method. Now I hope you're thinking, and you're probably thinking, why on earth would I use the shell method when the disk method is so much easier? Why would I ever do that? And I'll show you, because there are times when I use the disk method and there are times when I use the shell method. So let's look at another example. We're going to rotate the region bounded by y equals 3x, y equals 6, x equals 0 about the y-axis. And I'm going to use the disk method and the shell method to solve this same problem, just to show you the difference. Okay, so let's use the disk method first. I'm going to use a different color for each one so we can see them side by side. So for the disk method, I'm going to split this down the middle so you can see them both side by side. So for the disk method, I'm going to draw this picture first. So we've got 3x. This is 6 up here. This is 2 there. So the region bounded by y equals 3x, y equals 6, x equals 0, that's this region here. And we're going to rotate that around the y-axis. So if I were to rotate this around the y-axis, I'm going to duplicate my line. So I'm just going to reflect it and then make it look like this. Okay, each of my little representative cylinders that are going to be stacked look like this. In order to find the radius, then I need to solve this equation because right now I have y equals 3x, so I need to write this as x equals 1/3 y. All right, since we're integrating along the y-axis, in other words, all of these cylinders are stacked along the y-axis, I know that the radius of each one of these is 1/3 y, and we'll integrate from 0 to 6 pi times the radius squared times a little bit of depth to them. So I get 1/9 y squared integration 1/27 y cubed. I'm going to plug in 6. 1/27 times 36. I'm going to plug in 0. 27 times 0. And I get 36/27 pi, which reduces to 4 pi over 3. Did I do that right? Oh no, because it's 6 cubed. It's 216, not 36. You caught that, didn't you? You just didn't want to say anything. So it's 6 cubed, which is 216. And then 216 over 27 pi is the same thing as 8 pi. Okay, so that's the disk method. Now let's look at the washer method. I mean the shell method, sorry. Let's see, what color should I use? I'm going to use purple. Let's look at the shell method. I almost said washer again. We're going to take that same exact region and we're going to still rotate it about the y-axis, but we're going to use the shell method instead. So I should have duplicated my image before I drew all over it. Here's 6. Okay. My representative cylinders are going to look like this. Let me try this again because that's not a very good picture. My representative cylinders are going to look like this. Well, this time, the nice part about using the shell method this time is that the radius of this cylinder, no matter where we are, is all the same value. And since those are all horizontal radii, the radius is some x value. The same x value all the way down. The height is going to be determined by where we are on this function. So we need to find the height. Well, I know that from this point to here, I know that that's 3x. And I know that this is a horrible picture because I didn't go all the way up with my cylinder. So let me try it again. And I know that this whole height from the y-axis all the way up, I know that this is 6. So now I know that the height of my cylinder is going to be 6 minus 3x. Because from the x-axis to the bottom of the cylinder is 3x, all the way up to the top is 6, so what's in between is 6 minus 3x. The nice part about the shell method here is that I didn't have to rewrite the equation in any way. Everything is in terms of x, so it's going to make this problem a lot easier to solve. Okay, so to find this volume then, we're saying from 0 to 2, because that's along the x-axis, from 0 to 2. We're saying this is 2 pi, the radius is just x, and the height is 6 minus 3x. A little bit of depth to it. I'm going to pull out the pi, and I'm going to distribute the 2x in, so that gives me 12x minus 6x squared. Integration. Integration, 6x squared minus 2x cubed. And already the numbers are looking way better. We no longer have fractions to deal with. 2 squared, that's 4 times 6, that's 24. 2 cubed is 8. 8 times 2 is 16. And then plugging in 0, 24 minus 16 is 8 pi. A lot nicer numbers to work with. So here's my philosophy. When things are rotated about a vertical line, I use the shell method, because with the shell method then I don't have to rewrite any of the equations. When something is rotated about a horizontal line, I use the disk method. I'm going to do another example, but that's enough for this video. Look for the next video and we'll do another.